Welcome to AiTalks. We talk openly with customers, partners, and colleagues about the modern digital organization and how AI, cloud, and enterprise software is helping make real-world difference to our high streets, our workplaces, our factories, and so much more. So settle down and let me hand over to our fantastic panel today.
Hello, good afternoon. My name is Zoe Carberry. It's a great pleasure to have with me today my colleagues Paul Russell and Stuart Parker and Jeremy Dick from Purposeful Systems. A relaxed discussion and hopefully come up with some great personal points of view that lift the lid on why model-based systems engineering is a lot more relevant today than it ever has been before. So Paul, I'll hand over to you to get started.
Thanks, Zoe. Jeremy, about yourself, your career.
Yes, well, thanks very much. By education, I'm a software engineer. I have higher degrees in software engineering from Imperial College and worked in formal methods of software development until I worked for a company in Oxford who were developing a systems engineering tool, actually a requirements management tool called DAWS. Who hired me to do development, and I quite quickly got interested in the applications of this tool in the system engineering world. That tool was eventually bought by IBM and forms part of their software tool stable to support systems engineering. Right now, having worked as a system engineering lead in Costain for a while, I am independent. I run a little company called Purposeful Systems, and I've chosen that name because one of the things that I try to do is to encourage people to ask the question, for what purpose, which takes them a little bit out of the systems engineering arena into the more systems thinking arena, and to think about the purpose of what they're doing in a wider context.
And when I think about the theme, Jeremy, for today, I reflect on a blog that I read recently, kindly shared to me, and a quote from Donella Meadows in her book, Thinking in Systems. And the quote she came up with was, to change the way we act, we first need to change the way we think. And I think now with the world we're in, that cannot be more pertinent with the pandemic, Brexit. It's all making us think about what systems do for us as individuals, as citizens of the planet, effectively. So vaccine delivery, what do we need to do to get back on airplanes, getting food on our shelves, really making us change our thinking about systems.
Well, yes, it does seem as if the big issues of the day have a level of complexity that really require new ways of thinking. If you think about environmental change, about the worldwide pandemic, and closer to home, Brexit. These are complex issues because so many different sort of natural systems, social systems are at play in combination. So it's complicated to think your way through them.
Was it VUCA, volatile, uncertain, complex, and ambiguous? We have lots of phrases, and I know that we talk a lot about design and systems thinking. They are complementary and they're coming at completely different frames of reference. So I just wondered, when you think about design and systems thinking, how do you explain them to maybe a client of yours?
That as engineers, we like to start with a problem and think downwards into the solution. I think that when you're facing complex problems, you actually want to move in completely the other direction. You want to take the problem as it is presented to you and think upwards into the wider context, into more holistic thinking, and that's where the systems thinking really comes into play. And of course, we see that with this country's response to COVID, where the initial solution was to go straight into lockdown, which of course was saving lives directly from the virus, but by affecting the economy and effectively closing hospitals down to other forms of treatment, you were probably creating as many health problems as you were solving through lockdown. And to actually tease out and understand the effect that you're having on the economy requires true systems thinking. So I think how I describe it to people is in terms of those sort of upwards looking and downwards looking, and they both have important roles to play.
If you imagine as an onion, if we're unpeeling this onion, the role of software, which obviously is close to our hearts, and all that comes with it. So data, business process engineering, the role of AI. What do you think in terms of the importance of software as an enabler, I guess, for systems thinking and ultimately that model-based systems engineering that you're beginning to talk about?
Software has a very important role to play in terms of tool support for both systems thinking and systems engineering. Your analogy of unpeeling the onion is quite an interesting one, because I feel that actually a lot of the time we're not on the outside of the onion unpeeling it. We're sort of halfway in the onion and we've got to unpeel it from the inside, but we've also got to unpeel the outer layers as well to sort of understand the world.
Maybe we're going to have to come up with a new phrase that
The peeling the onion type analogy is what a lot of systems engineering approaches is about. But I think what Jeremy's been talking about recently with model-based systems approaches is really playing more to that analogy that actually you've got to move up. As per Jeremy, your opening line, you've got to move away from trying to solve the problem that's maybe the explicit one in front of you, but actually elevate the thinking in order to understand what the actual problem is, including all of that context.
Yes, something quite interesting has happened over recent years in the water sector. Ofwat in the UK essentially said to all of the water companies that they had to do something called systems thinking. And initially, really none of these companies knew what on earth that meant, so they all scrambled to try and understand what it meant. And what Ofwat meant by that was that the water companies were a bit stuck in a systems engineering mode where they would intervene in their water network by trying to fix components of it without really stepping back and saying, well, wait a minute, if I fix that component, am I really solving the real problem here? And a lot of the water companies have really seen the light and have started actually stepping right back and saying, actually, I've got a pumping station here and a sewage unit there, but they sit inside this much bigger context that includes the weather systems, the environment, the social implications of delivering water of the right quality. And some very interesting solutions to problems came. And I think down in one of the water companies, for instance, they found that they were repeatedly having to repair some water pumps. And somebody eventually said, look, instead of spending a fortune constantly fixing this pump, let's find a different solution. Why is it breaking down? He says, well, people are flushing nappies down the toilet and they are clogging this pump. So they said, okay, let's try a different solution. Let's simply make a publicity campaign to dissuade people from flushing things down the toilet. And when they did that, it worked a treat, and they found that they didn't have to keep replacing that pump. And that's an example of kind of systems thinking. It's sort of stepping away from the problem and looking at the wider implications. And here they were intervening in the system of social norms that exist in society, influencing it. And this is very much in the kind of systems thinking arena.
Jeremy, that's a very interesting example. But how would you advise an organisation, or how do you facilitate an organisation to start thinking that way and adopting those types of approaches?
Well, it's back to Dorothy Meadows. We have to change people's mindsets and get them to think in different ways. And this is interesting. This is where modeling helps, because models help you ask the right questions. And until you learn to ask the right questions, you don't get the right information you need and the right understanding. Just as, with systems engineering and model-based systems engineering, there are sets of tools that you can use. Now they're supported by software, but when I say tool, I mean modeling languages and structures that cause you to ask the right questions. But there are equally a whole set of such tools related to systems thinking. There are things, for instance, called causal loop diagrams, which is if you like, a modeling language that causes you to ask what the relationship between events and causes are, and it helps you build these models of natural and social systems and things. There are other things that are called affinity diagrams, which is a modeling technique that helps you understand, again, the relationships between things in the real world. These techniques, they're quite simple techniques, but they embody systems thinking, and they help people to have that broader vision of what systems thinking is all about.
Jeremy, models are in the news. I mean, I'm thinking about the examination U-turn. They've talked about models of exam results and how they were using algorithms, and then there was a U-turn, and then we see modelers on the news talking about the pandemic, COVID, and these people probably would never have seen. So we're now using that language models, or we're hearing it anyway. So is there something you could talk to about that in terms of, is this now the time where the use of modeling is going to become more, I'm not going to say mainstream, but more digestible by people who wouldn't have thought about it before?
Yes, it's fantastic, isn't it? Suddenly the news is full of people talking about models. And unfortunately, not very much of it is positive. I mean, we've had so much talk about COVID models and their shortcomings and why they're not predicting the right stuff. But they are getting better, of course. And I think the trouble is that people don't really understand what models are for. And another quote that I really liked from the 1980s is from a statistician called George Fox, who said, "All models are wrong, but some of them are useful." And what he meant by that was that the whole idea of a model is that you're not supposed to be modeling the whole of the world. You choose one aspect to model. And so maybe your model, and the aim is to make the model accurate in that one aspect, and therefore it is useful. And of course, what's happened with COVID is at the beginning, the models that people had of the pandemic had not had enough time to be calibrated from real world data. So it was quite academic, as they were sort of imagining what must be going on. And as more and more data has come along, the models have got more and more accurate because they've been calibrated. And actually that speaks to the fact that the kinds of models that we talk about with COVID and the, modeling the prediction of exam results and other things are very different from the kinds of models that you create when you are doing systems engineering, because in systems engineering, you are designing something. So you are modeling behavior and trying it out before you build the thing. Whereas, we talk about model-based systems engineering, but what we're seeing in the news is something quite different. It's model-based systems thinking. And there, the models are not exactly digital twins, but they are digital models, if you like, of some aspect of the world where you try to mimic digitally what's happening in the real world. And the reason you want to do that is because it's often the best and only way of actually understanding what's happening in the real world. And so your model captures your understanding of the world. And therefore it needs to be calibrated with real world data. And we've seen exactly that over these months of COVID. The early models were hopeless, really. But the models now, calibrated with data that's been collected on the ground, are becoming far more accurate.
And to that point, and that's a great clarification for me. Thank you. Are there any industries, examples where maybe people are on that journey to digital twin, but demonstrating real value today because a subset of their operation or their production or their manufacturing is using real strong aspects of modeling and that kind of digital model to real deliver value to their whatever their organization might be? If you've got any kind of examples you can share?
Well, yes, I was invited by a friend who works at the National Gas Centre, and they have digital models of the physics which they use, and it's been calibrated over time, so it really is an accurate reflection of physically what is out there. And so they are able to use it to raise alarms when behaviors of parts of the network are trending in the wrong direction. And so preventative measures can be taken to prevent things from going wrong. So it aids them in the actual operation of the system. And also they are able to take that model offline and use it to plan maintenance. So they can say, well, we're going to switch this part of the grid off. What effect is that going to have on our supply of power to the public? And so they can actually plan interventions in advance by using the model to predict what the outcome would be. And that already is sophisticated use of a digital model. Now, anybody looking at it would say, well, that's not a digital twin, because there's nothing very visible about this model. It's all, but nevertheless, it captures their knowledge of the internal workings of the grid and has very useful applications for them.
And Jeremy, what about on that, continuing that theme? Because one of the things that I know is a real focus for us is requirements, and many industries suffer from the initial requirement definition, and getting off to a bad start can create a lot of complexity, rework, cost, overrun, and so forth. And with many examples. So the role of AI in requirements definition is a very specific area. However, it's got much wider implications. So is there anything you can talk about, the purpose, the relevance of requirements definition using artificial intelligence to improve that quality?
Well, yes, it's a challenge, isn't it? Because we need a means of expressing requirements, and still now the most complete means of expressing requirements is in natural language. Although people have tried to argue that you can capture requirements in models, there are still whole rafts of types of requirement that our models don't reach. So we still have to live with natural language as a means of expressing requirements. We used to have a sort of rules that you could use to assess a set of requirements, to determine whether they were the right quality, which was a bit sort of after the event. So it's sort of, let's write some requirements and then let's assess the quality. And then somebody writes, well, actually, if we've got these rules for the quality, why don't we actually use the rules to create the requirements in the first place? And then things will be a lot better. And I think that and of course, to assess a set of requirements and its quality requires domain knowledge of the kind that lends itself to artificial analysis through artificial intelligence. And so I think that having an intelligence support in capturing a coherent set of requirements is a very useful thing to have. And a lot of the quality rules are to do with how to express an individual requirement, but the quality of requirements is not about individual requirements. It's about the set and how they interrelate. And have you thought of everything? Have you got a complete set? And are there any conflicts and contradictions. And this is definitely ripe for assistance from machine learning.
There is potentially a huge benefit to be had. You're talking about AI. You really need to get the help on the quality of requirement sets rather than individuals. And a role that AI could potentially play there is by analysis of previous definitions for similar systems, perhaps. So in other words, have we designed and built stuff with similar requirements before, and if so, is there overlap with those requirements, and are there checks that we can perform in relation to effectively maybe parent or child requirements to that, and that might actually allow you to learn from the errors that you made in the past.
Well, yes, and of course what we see increasingly is companies developing products that are componentized, if there is such a word. So in other words, if you look at the automobile industry, the number of components that are common across the range of vehicles increases year on year, so people are managing product families or product lines, which means that yes, your new model is not something completely new at all. It's probably only an evolution of things that exist already. And it reminds us that every system that we develop is actually part of a system of systems. And really, to be effective in developing a system, you have to understand the system of systems. And in a product family world, that system of systems are all of the systems concerned with the development of the components, and each component will have its own life cycle, and components can only be put together in certain design combinations, and the level of complexity goes through the roof, and the need for really good configuration management is huge. And so an intelligence behind the management of that kind of complexity is so important.
So this has been great. A big thanks to you, Jeremy, for your time and insight.
You're welcome.
And thank you also to Paul and Stuart. And to the listener, I hope you have enjoyed this episode of AI Talks. Keep safe and have a great Christmas. Thank you.